about things that people don't like to talk about because it's not cool, it's not sexy, it's not an incident, it's not the GDPR. But frankly, this is something that is probably just as important as anything is. If you assume your data is going to get breached or hacked, what are you going to do about it? How are you going to fix it? What are your responsibilities to the government, to regulators, and to everybody around a data theft or a data loss? So I wanted to start by just giving you a little bit of background about why we're here. And I don't know if anyone has seen this article. I pulled out some of the statistics, but it's pretty shocking. List of breaches, God bless you, over the past couple of months. DoorDash, 4.9 million customers. Dealer Leader, this is the prospective car buyer case that they left 198 million pieces of PII left open on an unencrypted server. Facebook, 419 million records, that sounds light to me. BioStar, VPN, 27.8 million members. Hy-Vee, that's the gas station attendants, 28.9 million pieces of PII. LabCorp and Quest, everyone's probably familiar with those two. It affected me. We had our stuff stolen from, my wife and I had our information stolen from Quest, which we use. And then the massive one again was First American Financial Corp. You don't know them pretty well, but if you have title insurance, you know First American very, very well. And that was 885 million pieces of PII, your most sensitive data that was just left open on an unencrypted server for anybody to read, for anybody to use. So, I get all this, and I understand the concept of we have too much data, we don't know what to do with it. I understand the data, I understand the concept of, well, it costs money to hold this data. It costs money to do something with it. We have cloud expenses. We have people resource issues. I get all that and I understand that. The reason I'm here is I'm a lawyer. I started my career with a case called WorldCom, which if you remember was Bernie Ebbers and Scott Sullivan and a major financial fraud. And I walked into my law firm on a Monday and they said, "You're going to be very busy." And I said, "Why?" "Well, we were just hired by the WorldCom board of directors on Friday night." And I describe this to my kids as, what does Daddy do for a living? Daddy is the guy where somebody says, "Go pick up the mess in the corner. Go clean that up." Like our dogs, sometimes when the dogs have an accident, except this is a much bigger problem than my golden retriever. Daddy has to clean up the mess. So I'm a cleanup artist by trade, but my job has gotten worse since July, where in terms of breaches and things like that, and it's gotten worse because of regulatory activity. It had always been bad in an SEC environment. When Chair Clayton came in, when Donald Trump came in, Chair Clayton hates cybersecurity. He hates the concept of it. People don't understand it, but he understands people don't do disclosures. They don't give breach notifications when they should. Chair Clayton hates cybersecurity, and he should. You know why? People hate cybersecurity now. I think, I've given the speech, David, many times. We're in cybersecurity 3.0 right now. Cybersecurity 2.0 was post-target, meaning we know something really bad happened. We don't really know why. We know we're not a target, and we know it's not going to happen to us. That's cybersecurity 2.0. So what cybersecurity 3.0 is, the public saying, we don't trust you anymore. We don't trust you with our data. We know you don't, we know you're not valuing it. We're in a big problem. So what happened in July? British Airways got fined $231 million. Marriott got fined by the British Data Protection Officer, $123 million US. July into August was Equifax, the $1.4 billion settlement with both the government and the states. Think of that mess. We're in cybersecurity 3.0, and people don't trust us very much anymore. and that's a bad problem if you're any sort of in data. You're in any sort of data solutions or data cybersecurity. Now, I don't care if you're the best practitioner in the room, and you may be great in incident response and business continuity. You may be great in what you're doing, or a great teacher or a great professor. But if we're not thinking about encryption and tokenization of our data, we're not thinking the right way, and we're not thinking for our clients. And that's why I am here. I want to introduce you to David from Eclypses. David, first, if we step back and we talk about, since I'm the king of fear, uncertainty, and doom, if we step back for a second, tell us a little bit about the concepts. What is encryption? What is tokenization? Right. And where does that leave the big data set? What do we do with it?
Yeah, concepts are now emerging so that there is the expectation that you're breached. There is someone in your system. They're going after the data. If they get to the data, then they get those discernible values that are going to ruin you either as a company or even as a human being when you're trying to unlock your car, the simple transmission of the unlock command from your key fob. People are breaking into these things. We know it. So the concept of tokenization is to take something of a discernible value and then individually create a substitute value and use that substitute value to store, to move between two endpoints, or to share, so that whenever there is that breach, like we heard about today in the opening session with Ron, this second layer of defense, this whole notion of a whole nother network, say, hidden within a network, the hackers, the adversaries are going after data in a known place in your known repositories. If they get to that repository and only find worthless substitute values, they get nothing. They get nothing discernible. And where is the real data and what's happening to the real data remains a mystery, but the adversary finds nothing. So tokenization is around that. Yes, you can hold on to a token and then at some other point recreate data on the fly when you need it. And that's the whole concept here, is preparing for the eventuality. I sat in a conference with the FBI maybe about 5 years ago, and it was an interesting conference because the guy who's head of cybersecurity at the FBI said this: there are two companies in the room, those who have been breached and those who don't know that you already have been breached. So everyone's breached. Like we heard this morning, it's there. They're looking for your data, they're looking for these commands, they're looking for discernible value.
So let me ask you a question. Why do people hate tokenization and encryption so much? I'll answer my question, and maybe you can help me with it. Here's what I hear: we can't use our data.
Right.
We're working on it all the time. We're a big healthcare company.
Yes.
We have to get our records out. We have to do this. We have to do that. We have to run analytics over it. You can't give us. If I have to encrypt and decrypt all the time, I'm wasting enormous amounts of time.
Exactly.
And you're spending my ROI.
Yep.
And you're screwing me up.
Right.
Where does tokenization come in, and how does it fix that problem today that most business leaders can't stand?
Exactly. And that problem is really known as accessibility. You can secure something so well you can't even get to it yourself. And those are the problems that we have. We're trying to keep the hackers and the adversaries from getting this data, and yet it's the very same piece of data that we need for our business, for our communication, that we have to have available to us at these near real-time speeds. So we want some people not to have access, and yet some people to have access when they need it. And one thing about a tokenization strategy is, when you tokenize an individual piece of data, you're not having to tokenize or encrypt everything. A problem with encryption is key management. If I have to have a key to unlock a whole column of data, let's say it's social security numbers, if I have to unlock everything to get the one thing that I need when I need it, boy, I've suddenly created a new attack vector. There's a new surface because everything's exposed for the moment, and then I lock it back up when I don't need it. Well, when you do things with a micro-tokenization process, I can take one piece of data and create a substitute value that then creates a key on the fly to decrypt a value, a single value in the moment that you need it, so that the right person can have accessibility to that data, and only that one piece of data. I don't need to open up everything. I don't need to now decrypt my database to get to the things that I need. I just decrypt and untokenize that one item, that one element when I need it, the moment I need it. Same with communicating data between devices, whether it's a medical device or a garage door opener to your house, as simple as that, or from a satellite to an unmanned robotic weaponized vehicle on the ground. That data that moves is an attack surface, even though it's in the air. And so if we can create those substitute values that transmit and then only reproduce in the moment that it arrives, now you've created a way to keep accessibility available to the guys who need it, and yet security from all the folks who are our adversaries.
So let me get further into the question, and I know you have a PowerPoint, and I want to make sure that we explain it all. Mm-hmm. Here's my layman's stupid idea about tokenization, and what I represent a healthcare or a hospital system. Mm-hmm. They have bills, mm-hmm. and they have to get their billing done, and they have to bill United Healthcare. They have to bill patients. Mm-hmm. But they also have lots of other electronic healthcare records on their databases. Mm-hmm. They have my MRIs, they have my CAT scans,
Correct.
They have my blood work, they have my lipid panel, which ain't so good, by the way. I didn't know if I just had my lipid panel done. Jesus, what a pain in the ass that is. So, they have all this stuff. What you're saying to me is, if I'm in billing, medical record billing, and I need to get my bills out, but I want to do it securely, if I have tokenization, mm-hmm. I don't have to unlock all of my personal healthcare stuff. Right. That could be really problematic when Paul's cholesterol is 200. Mm-hmm. I don't have to do that, right? I can just unlock what I need to get my bills out, my charges.
Right. Now, are you trying to hack into it so you can change your records?
I would love to hack my cholesterol lipid panel. Absolutely.
No, that's exactly the point, is that then when you can tokenize something individually, then I, as a human who own my own data, even though someone is in charge of it and a medical company has my own records to it, I can make it so that it's only permissionable by me when I want to use it or when I want you, the doctor, to use it. When you now have that individualized token process for any type of data, regardless of that MRI file, the cholesterol chart, or even the payment data for my HSA account around this, I can now make that token a permissible event to say, all right, you need to look at my record now, doctor. I'm here with you. Now you can unlock it, and only that record in that moment that I allow you to. So even the doctors like this, because one of the problems with HIPAA is if there's a breach, these doctors, these medical companies, they get massive fines. In fact, it's the most expensive fine right now out there. As a matter of fact, it's the most expensive data on the black market is a health record, because it gives so much information about that individual. They can build a profile, they can go get loans against this, all these things. So if I now can control it as an individual, the doctor is relieved of that burden. He does not want to have an actual file in his database. He would rather have a token. He doesn't have to worry about a breach now. If someone hacks the doctor office, they get these worthless values, and yet still in control over it when he needs it, when I give him permission. So it becomes now a win-win-win situation. And then lawyers have to look for new work.
Shit. Sorry. Listen, I know you have a PowerPoint, David. Just show us a little bit about the process and how does this all work in actuality if we wanted to use tokenization on our data sets.
Yeah, the whole thing is we know that bad guys are after the data, so stop using it. Use these substitute values instead. And then when you're able to pinpoint, choose what data you want to use, you have faster accessibility to it. You don't want everything secured. There's not a database in the world that needs to be entirely secured because there's so many worthless values in there, pointers and little other records and things that aren't a security threat. But the ones that are, now you can identify those and pinpoint that type of data that's going to ruin you if there was a breach. We now can protect. And it kind of works like this. You have existing systems, you have existing architecture, you have the things that you've already invested into. All we do is say, identify that record, hand it to the micro-token exchange. We create a worthless value on the fly. Any micro-token that we do is unrelated to the source value. It's not a hash. It's not take some of the data and then create an algorithm to reproduce a substitute value. It's just a worthless value. And then you store that, you share it, you move it between your endpoints. When it needs to be reproduced into the form of a real data, providing all the business rules are met, the proper authentication is met, the credentials are there, then the MTE goes and reproduces the data in that moment and makes it back available to the systems that desire it. Again, it's a whole set of services that are able to be installed on-prem or off-prem. And it protects data at rest. So this means anything that you have to store. You know, when there's only a couple things you can do with data, you can store it and wait to use it, or you can move it someplace and use it. You can move it into an application and view it. You can send a command to the car to unlock the door. Now you're using it. So it's either coming from someplace or going someplace, right? You can store it or you can move it, and that's real simple. And so if you can develop cyber strategies around those two places, then it complements all the things. Like we say all the time, we're not an application company. We don't know what your experts know. We're not software engineers in that way. We're cybersecurity algorithmic engineers who know what to do with data. So we provide a nice set of tools that you can consume into those existing platforms so that you can protect what you need to and pinpoint it. Maybe you don't have data moving that you're worried about. Maybe you just have data at rest you're worried about, or some combination of it. These tools can be designed to complement that cybersecurity. We're also not keeping people out. Again, we're assuming you're trying to. We want you to practice the best network strategies out there. We want you to keep people from trying to get in, or your intrusion protection stuff, sure. But we're past that. We know that it's going to happen. So what are they going to get? They're going to get these worthless tokens. So data at rest is that. It's stuff that is stored, waiting to be used. Data in motion is the stuff, the commands that have to go from one point to the point. And again, this whole now reality of microtokens allow for us to do that one thing when we need it. So a couple other things that is emerging besides just non-secure IoT type devices. You know, that's another problem we heard about this morning, is with the emergence and the billions and billions of connected edge devices that are out there, so many things are cropping up without a security strategy in that application, in that device. A lot of really cool things have been developed, a lot of really neat mobile apps, and even with the emergence of blockchain and distributor ledger technology, we've got neat things happening that make our lives a little more simple and fun without the security. And interestingly, you as humans, me as a human, we willingly give this data available to these systems, to these applications, basically knowing we don't have security, and we're just making our stuff available to anyone who wants it, giving ourselves actual liability to the whole thing, because we click the end user agreement that says, hey, we don't have security, you're on your own here if you get breached. Not quite, but you know what I'm saying, Paul.
Basically.
There is no real way to control that. So even in the connected devices, even when you're on your browser session, even connected right now, communicating back and forth to whoever you're texting, these communications aren't secure. They're very breachable. So even we have now created some fun ways to think about security, because on that internet connection in your browser right now, you might have SSL, but that's really not security. That is a fake security. But when you're now typing that value into your bank and saying, I want to execute this trade, and I want my bank account to transfer this money into my stock account so I can capitalize on this stock trade right now, I'm typing data in, and hackers can sit there on these open networks and watch the data movements back and forth and see exactly what you're doing. They have reached points to what you have. Well, if you can bring down a micro-token exchange into that browser session, nothing to install, now I can communicate worthless tokens back and forth between my session and that web server, and no value is ever moving. Only the endpoints can reproduce it upon receiving it. And we can, you know, after the session, we can talk about the real ugly technology behind it. Actually, it's brilliant. But
because you wrote it.
Yeah. But these strategies now can be taken to your endpoints. I know a lot of companies worry about what gets brought in, the BYOD stuff, what is brought into their organizations. If you can secure even these innocent mistakes that people are making by opening up sessions in that office location, you know, and you can control the data moving back and forth between that session and that endpoint, you're protecting things that also are bringing in these malwares and these Trojan viruses. We can eliminate all those things. So part of the defensive strategy that we have to have for cyber means not just best practice, but new practice, new ways of thinking about the value of data. Is the data valuable, or is it necessary? Is it a requirement? Once you go through the thought process of identifying all the different things that could happen, you now can create a great strategy to protect it.
So let me ask you a question. I think I'll yell and scream. Here's what I hear a director thinking.
Mm-hmm.
This sounds really good, but it sounds really freaking complicated. And I bet it's going to take months for you to set this up.
Right.
And in those months, I'm going to get my ass sued by the GDPR in California and New York.
Mm-hmm.
Right or wrong?
It's not complicated. This is now very, very simple, because the way we've designed it means that you don't have to spend a whole lot of time in development. On the screen is an example of what we do when we're communicating between two endpoints, like an Internet of Thing to some service that needs to work and do what just got sent across, like a command that says, now unlock my door. If you have the relationship with the software developers, if your organization has that software experience in-house, then our SDK and the API thing means that all you have to do is change a couple of lines of code in your application, compile a pairing mechanism, install what we call a build packet. So when you have something that is sending a command to unlock a door, inside of that device, a packet of data gets built, and it goes and sends over its existing communication protocol. It could be Bluetooth or Wi-Fi or anything, we don't care, but a packet of data moves. So we're simply saying, before you send it to your communication protocol, call this build packet, we're gonna change what the data was into these fake values and tokens, and then we're gonna send it to the other side. And then when you compile that into your front-end application, and then compile the deconstruct packet into your receiving device that has to execute a command, it's just now, instead of calling what you would have called to take in that packet of data and hand over to the applications and layers of the system to do something, you're going to call our build packet, our deconstruct packet method, and we're going to convert that back into these actual command values. So nothing ever moved between two endpoints except fake data, but upon receiving it, there's just a couple lines of code that calls this deconstruct packet. So we've had actual experience with some use cases and proof of concepts and clients where they have consumed these things in a matter of hours. And suddenly, in a matter of hours, your software engineers can consume this, make their endpoint secure. So anything moving. And that's just an example. When you're storing data, that's a little different. And we have to understand what to store, where to store it, and create that other network, if you will, that other hidden defense zone.
But I'm GDPR compliant, and I did a data map, and I know where my shit is. That's gotta help, right?
Yeah, exactly. You know where it is, as a matter of fact, and now, because of the micro token, you can say, this guy lives in Munich, and he just requested that data now needs to be stored in a repository in Munich. Well, we don't have to now build databases. We don't have to have anything running in Munich other than a file system, some kind of file share, and we dump in an encrypted blob of data on this receiving side and wait for it to be used. The data originate or is stored where it originates, but the people who are using it and analyzing it and have the applications can be wherever they want. And then when I need to bring that passport file back from Munich, then I can look at it with that right permission.
Excellent. Another question. I don't have one office. Mm-hmm. I'm a healthcare system with 14 different hospitals, 24 ambulatory centers. Mm-hmm. I've got people up and down the Northeast. This sounds like just a mishigash. Can I do this? Can I use tokenization, multiple locations, multiple places, multiple hospitals? And is that going to significantly delay a rollout of the safety that the tokenization provides?
Well, I say no. It sounds complicated, but it's not, because again, the same strategy is true no matter what location you have. You have identified certain types of data that have to be secured. Whether it is in a location in the same state within that hospital's own internal network, or if it's in a cloud environment and it's remote someplace else, this simplifies the need for massive system updates, because when a hospital system acquires another hospital system, they might acquire another ERP system, a different payment platform, a different even a system that views medical records. You know, all of these things.
Multiple systems.
Multiple systems. And this actually simplifies that, because remember, we don't care about the front end system or that database repository. We care about then what is stored and what is moving, and we convert it to that receiving endpoint when it needs it. So it makes it so that these kind of rollouts, you don't have to think about everything and all systems changing. You just think about the data only. And the data is consistent throughout any system. It's something that's interpreted, right? It's something that comes from a storage and then is used when it needs to be used. And so this system means I don't have to reinvent that wheel of trying to consolidate everything. My data is my data, and I'll just protect it.
So I want to give you guys some times. I know we're standing between you and lunch, and that's always a bad thing to do. It's like when you're giving a speech and you're between you and the cocktail hour, you know, you got to end really quickly. So I think, and David's going to stay around, and people are here all day from the team to talk about this. I look at encryption and I look at tokenization and say to myself, I'm a director. I have big data sets. I've just seen Capital One get sued up the you-know-what for having 100 million pieces of PII get stolen. What am I doing about it? Am I secure? Am I not secure? I think if, and by the way, and if I'm in Europe and I'm under the GDPR, you may be aware that there is a supposed safe harbor under the GDPR if you anonymize your data. Think about that. So I think from a legal perspective, from a risk perspective, from a board perspective, we need to change our way of thinking. We need to change the way we're thinking about data sets, data storage. You know, we're the best. We could be the best, and we are the best cybersecurity people in the world here in New York City, and we're really good at what we do. But you know, if Russia or China is going to hack us in a concerted way, we're not going to stop it. You know, and I've been involved in those cases, and that's a big problem. So I think, you know, I'd urge you all to think about, and the reason we did a little different presentation here today with our friends from InfraGard is we got to think of new approaches to, you know, to data security. And I think one of the approaches that's been to date ignored is tokenization and encryption. People have just not thought about it as viable. Now we're at a point in time where we're at the non-enterprise level where we can tokenize big data sets and keep them safe and secure. So before we break here, any questions?
So if I understand this correctly, a token is really a policy assertion that if I'm authenticated as a certain user and let's say I'm on a certain device in a certain time of day, then I'm authorized to read that data element. And at that point, what happens is I open up like a TLS tunnel, agree on a symmetric key, and then it gets encrypted on your side, and you send me the encrypted packet, and I'm able to decrypt it.
Everything up until you say open up a TLS tunnel. That's not required now, because you're not even sending a piece of data. You're sending this token, and our system, and it might require something offline here, but we take that value, we convert it into token substitutes, send the token substitutes, and then reconvert it algorithmically back into the original value. So now, even in the military, you don't have to have a military VPN tunnel in order to communicate sensitive data to your commander. You can have someone on the field, on boots on the ground, communicating directly from any device because the TLS is not there. If something's breached at that point, if something gets pulled out of that air or in the movement of that data, even in a non-military sense, there's nothing there except random tokens that are instantly obsolete, can never be used again until, I mean, not until, but then when the next message is sent, whole new token sets are generated and sent as a substitute. So no, you don't need that TLS connection. It's a replacement to it, frankly. Yeah. Yeah.
Did you say, like, as the owner of the data being the first, they would have to authorize every instance of when somebody was requesting that token?
Yeah, and that's an implementation setup. Say, for example, there's a lot of emerging mobile wallet type things that allow me to house and hold securely my own KYC data, my medical records, and things like that. And then when I need to, they're in my own repository, not on my device. My device is holding the permission pointer, not the actual data. But then I can take my handheld device to my doctor and say, yep, I'm here. You now have access to my cholesterol record, my MRI file, and my this and that. And I touch, and then the permission goes to that doctor's device and say, okay, now access this data. So these things are emerging, but that would be an example of how that works. So the implementation, the application provides the ability for you to select permission, but it has to be a predefined system. You can't just walk up into a platform and say, now I take control, if that application hasn't been built to give you that control.
Are you offering some basic database functionality on your site? Say I want to do something like a sort. Do I have to go give you all the tokens of all the records I want to sort, get all the data back through the sort, or?
It could be as simple as that, but in a lot of these things where there's analytics being done on data, then we would work with the implementation strategy to help you identify what are you analyzing, and are you analyzing the secure pieces, or are you analyzing like a demographic where the secure pieces aren't needed? You know, some systems say, I want to see all of the 20-year-olds to 80-year-olds who have cholesterol over 200. Well, I don't need to know the names of those people until I need to know the names of the people. So I can still run my analytics on the things that haven't been tokenized, and yet then when I have to now pinpoint get that, then I can take my report and then less data has to be de-tokenized.
But if I'm customer service or whatever, and I'm dealing with customer X,
Yeah.
and I want to know all records for customer X, how do I?
Yeah, then in the application, they would make an API call to our service with those 7 tokens or those 19 tokens or even those 1,000 tokens. And in real time, near real time speeds, meaning sub 5 millisecond, that data is now made available to you. The real clear data. And your application now sees David Schoenberger's social security number and all these other things about me.
Question in
Does
front.
the token live within the institution that is using the token, or does it live in where is it? Is it
The
inside
token,
the bank?
the token
or
is, yeah, the token is in your existing application repository.
Okay.
And then wherever the services are running to de-tokenize it, like when you need the real data back, where that API call is made, everything on that side, that set of services running, it's a configurable. Do you want it running in your data center? Do you want it running in some cloud center? We have services that can run on your behalf, but it's just a choice. Like in a medical company, they're going to say, run it all in my own data center.
Right. And then how much faster or more efficient is it than encryption?
Well, it's a lot more fast because the way encryption works now is now I have to decrypt a whole bunch of stuff to get the one thing that I need. Because we do one token, one piece of data, one key for encryption of that one piece of data, we're only returning one thing. So it actually speeds up the retrieval of anything that you have. Now, if you're doing nothing right now, yeah, this adds something, because if you're doing nothing, now we're doing something. But if you're doing just standard encryption, this is remarkably faster. And it can go even to a microcontroller because of how light of a footprint this is. Because encryption isn't the key here, the key is tokenization. Now we can run it on microcontrollers, microprocessors, servers. You know, now we have a lot more refined endpoints that we can deal with.
You have one last question?
Okay. Sure.
Oh,
I was
question.
just, and how do you?
You're double dipping. No, I'm joking.
Sure. So, do you have an approach for unstructured data, file shares?
Oh, of course, yeah. We treat any data agnostically. I don't care if it's unstructured or structured. Even and after this, I could show you live streaming video, every frame of video being converted into the token packet, and every packet delivered, instantly obsolete, returned with the new encryption key, and all of this stuff in nanosecond speed between everything being regenerated. I mean, it's remarkable. So, yeah, it is.
Okay.
But you don't have the anthem problem, which people came up with back in 2015, where if I have to decrypt 85 million pieces of healthcare information, how long is that going to take me? Now, that's always been the big.
Between each endpoint?
Yeah.
Or, yeah.
Yeah, and that's the rub, and that's what tokenization changes. So I was keeping track of questions. I recognized the gentleman in the blue sweater in the corner. And by the way, David Gomes and David Schoenberger will still be around after the presentation. They're not hungry. Their lipid panel is fine. They don't need to raise their blood sugar levels like I do. So last question.
Oh, no, I have some questions after, so.
Oh, and then we have time for one more question.
So you mentioned that the API call is actually needed to convert that token, and you said that it should be in the premise.
Yeah, the API call is necessary for data at rest. When I'm moving to data from one point to another, an API call isn't there. Those methods are installed.
But you can do the hosting on the premises, right?
Yes.
So it
Absolutely,
can't be-
yes. But even then, because of that second layer of defense that you're going to create, sort of that hidden network, your main database and systems and ERP systems are going to run, but you're still going to make an API call. Even if it's on a server right on the next blade on your rack, you're still going to make
How
that
much latency
API
you
call.
introduced?
We introduced in
this
your
scenario where it's
scenario,
close.
nanoseconds, and we have an example where we've got 8 nanoseconds. We've got an example where it's even in the picosecond thing, and I can show you some of this stuff. So yeah, when you're on the same network, we're introducing hardly anything.
Please thank David Schoenberger for coming from Chicago for today. Colorado, sorry. Out west.
On behalf of the conference, gentlemen, both of you, outstanding performance. We'd like to give you appreciation.
Lunchtime.